Learn about the latest technologic innovations today.
And you don't have to pay.
Expert panels with advanced degrees are sure to satisfy your curiosity.
Did we mention it's free?
And if you think you'll find a better time than this, then come on down and test your hypothesis. Cause you're gonna learn a lot if you wanna stay down at the Science Cafe.
Good evening. I would like to welcome you all once again to Science Cafe of New Hampshire. My name is Rick Irving, and I will be your host and moderator for this evening's session, which is our April 2021 session and our 10th virtual session. The session tonight is entitled Heat Pump Systems, Saving Energy and Money Today. Modern heat pumps offer a chance to dramatically lower consumption costs for both heating and cooling. Innovative technological advancements in HVAC products, such as a single unit for both area and water heating, and systems that operate at a much higher efficiency, can directly translate to cash savings in your pocket. So if you are buying or building a home, if you are updating, renovating, or making improvements to your current home, or if you're just interested in learning about HVAC advances and savings on your operating costs, please stay tuned and ask your questions to get answers from our expert panelists. Ultimately, that is our goal at Science Cafe. We provide a forum to enable the public and the experts to engage in an exchange of ideas based on scientific discussion. As is our norm, this discussion is generated by the questions submitted by you, our audience, to the panel of experts we have assembled for you tonight. In fact, you may submit your questions starting right now and for the duration of the session. Use the comments section of Facebook or YouTube, whichever you're using to watch us this evening, to send your questions directly to us. As always, we will get to as many of your questions tonight as time permits. Also, we ask, please be succinct with your submissions, and if you would, for general information purposes only, please include both your name and your location. Okay, and now I would like to introduce our panel to everybody. First, we have Tim Austin. For 24 years, Tim has been the owner and operator of his successful plumbing contracting business here in New Hampshire. He has significant experience in the residential sector of the home heat pump business, and he's been on the front lines for quite a few years. And I hear in the 80s, he spent quite a bit of time replacing first-generation heat pump systems. So, Tim, if you would, take a few minutes and tell us about yourself, your background, and your experience, especially as it relates to heat pump systems and cost savings, the topic tonight.
Well, basically, I've been in the plumbing business since I started working for my dad when I was 14. And been on my own now for, I think, after my dad retired, I think 28 years ago, something like that. And as far as the heat pumps, I've had really good luck with them. They're very efficient, and every person I've ever installed one has been happy as far as the mini splits go. And yeah, that's basically it. I've been doing it for a long time. Mostly residential stuff. I've always been impressed with how efficient they are. I even have a few in my own house.
Great. Thanks for taking the time to join us tonight.
Yep.
Next, we have Ben Schwinbauer. Ben is a senior research engineer at the Minnesota Center for Energy and Environment. Ben has a master's in mechanical engineering from the University of Minnesota and his BS in physics from St. John's University. Ben conducts research on new and innovative technologies for energy-efficient residential and commercial systems. He has a focus on water heater performance and service and residential HVAC systems. In addition to his research, Ben also has written several papers, and he has made several presentations at conferences around the country. Ben, thank you for joining us tonight. Tell us about yourself.
Yeah, I've been with the Center for Energy and Environment here in Minnesota for about the last 15 years doing research, and what that mostly amounts to is taking new innovative products, putting them into houses and buildings with a lot of data and collection equipment and monitoring equipment, and tracking their true performance, how they really work when we put them under kind of loads in real applications. And doing a lot of data analysis and writing up those results to help support sort of market adoption and utility programs and things like that.
Okay,
And
great. Thank you.
we installed our first heat pump in this manner in about 2015 or so. So we've been collecting data on heat pumps for quite a few years now.
Excellent. Great. Thank you for joining us tonight. I should let everybody know we have a third panelist that we hope to show up, and I will introduce him to the audience when he appears. So now we're going to start with our questions, and the first one is for Ben. Just so we can all get calibrated, what are heat pumps and how do they work?
Yeah, so a heat pump is a heating and cooling system that is installed in a wide range of applications, residential, commercial, industrial, for space heating and water heating. Mostly you can think of it like an air conditioner. It can cool your home, but it's also capable of heating your home. In winter months, the heat pump pulls air from cold outdoor air temperature and transfers it inside the conditioned space. In the summer months, it does the opposite, where it pulls heat out of your home and dumps it outside, providing cooling to the conditioned space. They're powered by electricity, but primarily rely on transferring heat through using refrigeration cycles kind of year round. Simply, heat pumps are really air conditioners that have the added value of being able to run the refrigerant cycle in both directions so that they can provide heating in addition to cooling. In recent years, they've been gaining quite a bit of traction for a wide range of reasons that I'm sure we'll get into, but primarily benefits around kind of combining those heating and cooling loads in a single system, being extremely high efficiency, and providing electrification for space heating loads.
Great, thank you. So now they're just basically one unit these days, right?
Yep.
Because I should be ashamed to say mine are two separate units altogether. Okay, thank you, Ben.
Yes.
Now, for Tim, what are the most important factors that you take into consideration when you're recommending a particular heat pump system to your customers?
It depends on what they have there already for a heating system or a cooling system. A lot of places have a central heating and cooling system, and for ones like at my house, I put in two mini split heat pumps because I heat with hot air, but I heat hot air with wood, and I couldn't really add air conditioning to that. And the heat pumps are great for picking up the slack on marginal weather like this when it's 50 out, and you just crank up the heat pump, you heat it up. I mean, they will work. The hyperheat ones will work to 15 below. And if you want to rely just on that, you could. But for me, it's mainly for backup. So, but and again, if people want air conditioning and they don't possibly have a way to run ductwork, which a lot of times they don't, then the heat pumps are an awesome idea for heating and for cooling older houses or retrofitting even newer houses. So it's kind of it.
So when you mentioned heat pump splits, what does that term refer to?
Okay, I should have said the mini split heat pump systems, which are very popular and efficient, which is kind of what we're talking about anyways, mostly. So.
Okay.
Yeah. I mean, they do have central heat pumps, and they've really come a long way with those. I know one brand, Fujitsu, makes a 20-seer central unit that they're doing a lot of change outs and taking out gas and oil furnaces and just using that in existing as a furnace. Okay. For a heat pump. So it's a heat pump for the whole entire house, which really is a pretty cool idea. They come so far with the efficiency of them. But mostly with me, it's been mini splits because, again, so many old houses don't have air conditioning, and people are finally not sick of having too much heat upstairs in the summer. And so they work great.
Good. Excellent. Thank you. That actually leads right into our next question from Courtney in Asheville, North Carolina, whom I know very well. What should the average homeowner think about when investing in a new heat pump? Either one.
I'd say this aligns a lot with some of the responses Tim just gave. I think a big part of this is that there are, a few different types of systems that we can think about when we say heat pump. And so it's really is trying to match the heat pump system with what the current house is using. If it needs backup, if it has a central system or a distributed system. And so I think those are some big keys when you're thinking about investing. And then I would say is kind of what are your goals? So are you looking for an economic savings? Are you looking for an emissions benefit? Do you want to go, to electric heat? those sorts of questions will help determine what type of heat pump application best fits your situation.
Interesting. So, Tim, if this was a heat pump system installed in the 90s, for example, what would you expect to find, and what would you recommend?
As far as changing when it was installed in the 90s, you're saying?
Yeah.
Pretty much, or yeah. Well, it all depends on what you got there. A lot of the original heat pumps, they first came out with them in the late 70s, and they were really horribly inefficient. But these are nothing to do with mini splits. They were just, one through the wall heat pump or one heat pump added on, and they usually didn't work at all when it was below 20 degrees. But again, I'm talking one central furnace-like heat pump in the ductwork feeding the whole house. And that's the best way to put this. The nice other thing about the mini splits too, they have an almost infinite amount of systems you can install. You can put up to over four mini splits, in other words, wall units or baseboard units, ceiling units, whatever, on one condenser. And I've done those quite a few times. And people like that because you can individually zone each room, or you can have one upstairs and one downstairs, like I have in my own house, just so for the AC, because of course in the second floor you need more AC than heat. And on the summer, in the winter, you need more heat. How about this? More heat than AC on the second floor because you lose more through the roof. But again, the individual zoning, people really like that.
Okay, great. Thank you.
Yeah. Yeah.
So from our next question from YouTube, Larry Gilbert. For someone with reasonable handyman skills, can I install a heat pump by myself? And what special tools are needed?
Do that one. You're supposed to be certified refrigerant handling before you can vacuum them and charge them, everything like that. In other words, you don't go to Home Depot and buy refrigerant. Okay. I'm not saying people haven't done it and won't do it, but actually most of the manufacturers frown on that, because if you don't pull a proper vacuum on it before you charge it, the system won't last very long.
I guess the one caveat I'll say is there are a few manufacturers that are starting to come into the market that want to be DIY installable, and so they come from the factory with all the refrigerant taken care of.
Yeah, they do.
They're pretty new. We haven't, we've put a lot of heat pumps in and seen how they've worked. We haven't put those in to know, what issues might come up from that. But I think it is a thing manufacturers would like to get into. But I would agree that the vast majority of heat pumps are probably outside of a handyman skill set.
Okay, excellent. Thanks. So how new are those heat pumps, Tim, the do-it-yourselves?
I'm not sure I quite understood that. As far as the do-it-yourself part,
yeah,
like I said, I don't. Most of them come charged for 25 feet of tubing. Okay, in other words, the condenser unit just has a charge in it, but you're still supposed to install it, pull a vacuum on it on everything you've installed, and then open the charge up and let the charge into it. And from the factory X I've talked to, they don't want. But again, this will probably change, but they don't really want homeowners doing it, because if you don't pull a proper vacuum on it and do a clean install on the system won't last too long. And if you have problems, then you call the manufacturer saying, I got a problem with this or that, or the people you bought it from, and it's just kind of a headache. That's all.
Right. Okay, great. Thanks.
That's my opinion. Yep.
The next question again is from YouTube, from J. Scott Raymond of Nashua, New Hampshire. You both appear to be talking about air source heat pumps. Could you address ground source heat pumps?
I can a little, but I've never done one. I've seen them, but I've never installed one. So,
you want to give it a shot?
Yep. Go ahead.
Oh, we've worked with ground source heat pumps some as well. So that so I guess the big difference when you talk about air source heat pump, that's got it does heat transfer from the air outside your home, and so the outdoor piece to that system looks very much like an air conditioner. Ground source heat pump pulls heat out of the ground through a few different methods, but typically requires you doing some burying of something in the ground and pulling heat out of the earth. And so there are some definite advantages there. You have more consistent efficiency throughout the year because the ground temperature is more consistent than the air temperature. And we've seen some really impressive performance out of those systems. Traditionally, ground source heat pumps are expensive because you have to do quite a bit of digging to get the outdoor unit in place. there have been a lot of innovations in recent years to get those costs down. And so they are, there are good applications for ground source systems as well. I will say from our experience, just in trying to get these systems installed, air source heat pumps are just more cost effective for a wider range of installs. But there are definitely cases where ground source is a really good solution.
Oh, very
And
educational. Thank you.
I've seen some water source heat pumps that a contractor not too far from me has a very good well that makes over 300 gallons a minute. And they actually use a water source heat pump where everything is in the house, because you just take this unlimited quantity of water, suck the heat out of that, and you actually dump it outside. Actually, he has a quarry that he dumps it into, so it's not even going to waste, so to speak. And that, again, like you said, Ben, is that it's always a consistent temperature. If you're pulling it out of the ground all the time at 50, you're going to get a lot more heat out of it than you will out of 10-degree air outside for air source heat pump. So if you're lucky enough to be in a situation like that, it works great.
Oh, excellent answer. Thanks, guys.
Yeah.
Next question. Fried Up from YouTube. Is there such a thing as ductless heat pumps, air source? If so, does it work compared to heat pump using ducts? And do you recommend ductless air source heat pumps? Yes,
that's what we're talking about. The mini splits are ductless. In other words, it's hanging off your wall, your ceiling, or some of them are baseboard or even floor things, and there's no ductwork involved at all. It just blows right into the room. The good thing about those, they're the most efficient. The bad thing is, of course, is some people don't want something hanging on their wall. So,
yeah, I will say that's one of the barriers, I think, for heat pumps is that there is a lot of terminology and a lot of overlap, and different people use different words. And so there is takes a little while to get everyone on the same page.
Okay, good. Next question again from YouTube. Sheila Zacher. How much square feet do heat pumps cover in a residence?
My basic rule of thumb is 1 ton of cooling for 750 square feet. And that's, it all depends on how big of a heat pump. In other words, if you're using a mini split, where it will blow, if your one room is 750 square feet, you want a ton of cooling in there. If you're doing a whole first floor at 1,500 square feet, you want 2 tons, or possibly split into 2 units so you do a better job covering the whole first floor if it's wide open. But I think 750 square feet per ton is pretty much a standard rule of thumb anyways, a rough gauge to go by.
Okay, great. I see Ben nodding, so I think we're in agreement.
Okay.
Next question from Courtney Wood again. Would installing this heat pump have a positive environmental impact and help with climate change?
Yeah, so we've done a lot of work. We at the Center for Energy and Environment, we're pretty interested in climate change and environmental impact, and that's one of our big drivers behind pushing for energy efficiency. So heat pumps have a real unique opportunity in that they have really good efficiencies, and so in a wide range of applications, heat pump have positive environmental impact. And so how much probably depends very much on your specific situations. So if you're looking at replacing an existing electric heating situation, like an electric baseboard, heat pumps are going to be 2 to 3 times more efficient than that scenario. And so you're going to see big environmental benefits. If you're looking at coming off another fuel, it really depends on what type of fuel and then where you're getting your electricity from, how, clean your grid is, how much environmental impact there is there. In my area in Minnesota, we see that right now they're about break even with natural gas and a little better than propane. But if you installed one today over their lifetime, they would have significantly less emissions than a gas furnace due to that boost in efficiency and the fact that the electric grid is much cleaner and getting cleaner.
Okay, great answer. Next question is from Mary Danka. I'm assuming the mini splits are more energy efficient than a regular window air conditioner. Why?
Just because of the design of them, and their design all air conditioners are measured in SEER, seasonal energy efficiency ratio. And I think an average window one, because you have to make it small enough to hang outside the window, is like 7 or 8 SEER. It's really low. And these things, most of the Fujitsu, the high end ones, are up to 20 SEER. So it's like over twice as efficient, just because of the design. How can I put this? You have a lot more area of coil. The bigger the area of the coil, the more heat exchange you get, the more efficient it is, both on the inside and the outside. That kind of makes sense.
Okay.
Yep.
And,
window air conditioners are an entry-level product as well. So not only do you have more space to do it, you know, as you get to a better system, you just have more interest in kind of optimizing performance.
Hey, thanks. Next question is from Steve Ford. How do heat pumps, air source and ground source, compare with forced hot water or oil systems? Payback period. They're more expensive to install, but they save money over time.
Yeah.
Definitely, yeah. I mean, it depends. Some of these things, in terms of like specific paybacks, there's a lot of variables in terms of kind of what your rate structure is. Oil prices can vary quite a bit by area, and then utilities handle heat pumps differently. So it's pretty common that you might see a heat utility that gives you a special rate for electric heating or for your heat pump, and so that'll reduce it even more. But they can pay back pretty quickly. So we see just kind of in a standard situation that they save like 30 to 40% of your heating costs over a propane system, which is a little cheaper than an oil system in most scenarios. So you can see some pretty good savings out of these systems, and the install costs are coming down all the time.
Oh, that is significant. Okay, next question is from Jay Fogarty in Queechee, Vermont. Beautiful place. The Mitsubishi Hyperheat is great, but super expensive. Can someone get a lower price systems, or do you usually recommend the premium solution?
I personally would recommend the higher end ones, because you supposedly have less problem with them and you have more backup from your supplier. But you do get. I have seen some that are a lot cheaper. Most of the not going to name any names, but I have seen some that are a lot cheaper than the Fujitsus and the Mitsubishis. But you could, of course, yep. I recommend the higher ones.
The one thing I'll add to that is, I guess it somewhat depends on your application. For the ductless mini splits, I totally agree. That makes a ton of sense, because you're going to try to use them for as much heating as possible. We see a lot of times central systems being installed with another backup, so like a gas furnace or a propane furnace or an oil heating system. And in those cases, you often will be using those at really cold temperatures anyways. And so in those scenarios, it doesn't necessarily make as much sense to pay for that really good cold climate performance, just because you won't be using it. But if the goal is to use the heat pump as much as possible and provide heating and cooling throughout the year, then I'd agree that there's a reason those systems cost a little more, is because they deliver.
Great, thank you. And the next question, Tim, comes for a neighbor of yours, Ed Cook in Brookline, New Hampshire. Is ground source heat pump the same as geothermal? If not, what are the differences?
I'd say it's close. With geothermal, they're using ground source or water source. But basically, yeah, they sound pretty close to the same. You're taking heat out of the ground by having extensive piping in the ground, or you're taking heat out of the water. Again, if you have a really good well where you can afford to waste a lot of water and put it back in the ground and take the heat out of that. Does that make sense at all?
Okay. Ben?
Yeah, I think this is another issue where it's just terminology. I would say those two terms are used pretty interchangeably, as Tim's saying.
Okay. Next question is from Stacy Samoji, one of our associates. Can the heat pump be used in conjunction with a solar panel system?
Solar panel making electricity? I'm guessing he's got a solar panel making electricity. Actually, in the days of my youth, we used a lot of solar hot water installs back when it was late 70s to early 80s actually. But that was hot water making hot water only. Now I think it's people are only using it for electricity, aren't they? I think. And I'm not sure how you tie those together.
Yeah, so you can do it. So we've seen in areas, so the area right around where I'm located in Minneapolis has a high penetration of natural gas. And so most people have really cheap space heating because natural gas is so cheap right now. But we've seen an increasing number of people that really want to push to better environmental impacts and are looking at trying to electrify as many loads as they can, and then adding solar PV to offset those loads and reduce their reliance on the grid and have more renewable energy. And so we do see those installs. I would say the vast majority of them are still connected to the grid so that they don't have to have on-site electric storage, because your sun the sun is up during the day and your house gets cold at night. So you need to have, if you're going to try to go off grid, you need to have some storage to offset those differences in the peaks. But yeah, we see a lot of people doing both those installs.
Great. Okay, our next question from YouTube, Sally Mansour, apologizing for joining us late. The question is, can a heat pump system replace an oil-fired boiler that heats through baseboards, or would you install a number of mini splits?
I would go with the mini splits because the heat pump system, you could probably adapt something to make hot water with it. But even then, if you have hot water baseboard, unless the water is a minimum of 160 degrees, you get nothing out of it, because that's just something I used to do with a lot of back in the old days. And you figure 190 degrees hot water going from your oil boiler to your baseboard to get maximum heat out of it. And so the two aren't really combinable. That's actually one of the many times you recommend mini splits to get both your heat and your cooling, because they're not compatible at all. As far as taking out an oil boiler and putting in, I'm not sure which put in even. But
that's mostly true. I think so it's pretty common to do air to water heat pumps in Europe and Asia. They have these systems that instead of doing forced air on the inside, they use an outdoor unit that transfers heat from the air into a storage water tank in the home. And then they can hook that up to the boilers. As Tim mentioned, there are some issues with the water temperature. The heat pump can't put out 160 degree water. In Europe, they have a lot more radiator systems that are designed for lower temperatures that we don't necessarily have as many of. Though we have seen some retrofit applications where it just so happens that the house has so much extra radiators because they were so oversized that you can actually circulate some cooler water and still get performance out of them. So I will say there are a few small manufacturers that have started to import those systems into the US, but it's a pretty small market right now, and it's pretty hard to find a contractor. So if you're looking at doing this in the near future at all, I totally agree. Mini splits are the way to go, but it's an emerging technology area, and there are people interested in trying to make that work.
Interesting. Now, when you talk about the radiators and this stuff being popular in Europe, is that because of these legacy systems, as we'll call them, or is there some other advantage to having the European system?
Yeah. So, I mean, in general, there are a lot more heat pump applications available outside of North America, just because various places have had a push to get reduce emissions and go to electric heating, or don't have the wide distribution of gas that we have in America. And so there have been other drivers to get to electric heat and to get these applications out there in a wider range of applications. So they're just available more.
Okay, great. Thanks again. Next question is from Facebook, Nancy Greenwood. Does the compressor have to be situated out of direct sun for best performance?
Not that I've ever noticed. That's never been a factor in placing the compressor. The main thing with the heat pump is you want to keep it from being underneath an overhang, so the water doesn't pour on it, and you have to keep it up in the air so snow doesn't build up around it, a foot off the ground or whatever. But as far as sunshine, I've never had a problem with it.
Okay. Next question from Facebook, Patrick Lucklow. Here in New Hampshire, most mini splits seem to be marketed for their cooling capabilities. If I'm most interested in heat, how do I make sure I find an installer who understands the heating piece? That sounds like it's for Tim.
Just ask him, make sure it's big enough to heat the place. And again, you figure the BTUs that it's putting out and the size of the room, do you heat low? It's pretty simple, pretty standard. And make sure it's big enough to heat the place. That's all. And again, when you go with the higher end ones, they have what's called a hyperheat, and those are the ones that are designed to get heat down to 20 below, which is pretty good. So they'll work down to 20 below, which is the max cold around here anyway. That's about the only answer I have, I think.
Okay. Ben's nodding in agreement, I take it.
Yep. Yeah, talking to them,
yeah.
The ones that don't want to do it will tell you not to.
Okay. Next question is for Rob McCormick. It's nice to see so many questions from Vermont, from Norwich, Vermont. Good stuff. Any guidance on providing mini split protection, i.e. pre-filtration, for a small woodworking environment, in addition to or instead of LEV, and turning the mini split off during dust generating activities?
I am not sure. I've turned down a few jobs that people had because they wanted to put them in their shops where there's an awful lot of dust and things where they work on trucks because they want to cool their garage. And I can't really think of a good way to box them off or filter them. They have good filters on them, but you'll plug the filter pretty quick in a really dusty environment. Good question.
Okay.
Yeah.
All right. So read as an announcement, not a question. Okay. From Joan O'Connor. I put in a mini split last fall and love it. I left my propane heater that doesn't need electricity in a place as a backup in case there's a power failure. I got a substantial energy efficiency rebate from New Hampshire Eversource too.
Oh, cool. Yeah.
Okay. All sounds good.
Yeah. Yeah, I've heard, I'm not licensed in Mass, I'm in New Hampshire, but I've heard in Mass they're doing $1,200 per ton rebate up to 4 tons for taking out gas or oil equipment and putting in these heat pumps. The 20 SEER, they have to be high efficiency ones, which is like, wow, that's incredible, really. That pretty much paid for the materials of the system, so that's pretty cool. I don't know what New Hampshire's doing as far as that, but good statement.
Okay. Excellent, Joan. Thank you. From Jim Heath from Franklin. In New Hampshire, would you need a backup heat source with mini splits?
I think it's supposed to have some type of backup heat source, even if it's just electric baseboard heat or whatever. And I think that's as much for insurance companies as anything else. I think.
Interesting. Okay.
Yeah.
Great. Facebook, Jeremiah McLean. Do splits be installed at floor level rather than ceiling height perform as well?
I think so, because the baseboard ones, because sometimes people don't want something on the wall, they want on a baseboard. You can't see it as well, which I can see, aesthetically. And they have, most of these have adjustable air vanes where you, on the control, you can have it blow further up or further down for a ceiling one or a wall one. So I would think it'd be all right.
Yeah, the biggest thing we've seen with the lower down the wall ones is just they're easier to block the airflow because you have things lower in your house. So it's important to put them in a place where nobody's going to put a couch in front of them.
Okay, and then following up to that, what are some of the feature options to look for that make them more efficient?
I mean, we've talked a little bit about the hyperheat system for Mitsubishi. Most manufacturers have something that's similar. I think Mitsubishi prides themselves that they're kind of like an industry leader, but I think there are some pretty comparable technologies from other manufacturers. The biggest piece, if you're looking at really cold temperature performance, so like below 20, is that the compressor on the outdoor unit can modulate. And so that it can ramp up as it gets colder outside to deliver more heat. That's the big piece if you really want cold temperature performance.
Okay.
And I should say there are some NEEP, the what is it, NEEP, they have a cold climate specification where they kind of list all the heat pumps that meet their like energy efficiency in cold climate kind of designation. And so they have some specs that are around SEER that we've been talking a little bit about. There's HSPF, that's heating seasonal performance factor, and then there's like a efficiency at a cold temperature. I think 5 degrees outside is the spec, and so they make sure that all the heat pumps meet those criteria in order to be kind of energy efficient in a cold temperature application.
Great. Excellent. Okay, our next question is for Ben. From your research, what do you believe will be the newest near-term improvements that we can look forward to in heat pump systems?
I think the big things we're seeing coming out now, so like the actual kind of capabilities, like the raw capabilities of the heat pump technology they're increasing, but they've been kind of plateauing. So they're heating at really cold temperatures and they're really efficient, and there's marginal gains there. But the innovation is really around applications, and controls. So how they interact, so if you have a ductless system in part of your house, but you're using baseboard in another part, kind of how those two systems interact with each other, or things like operating off dynamic electric rate structures. So kind of those control things. And then on the application side of things, just things like traditionally mini splits were like one outdoor unit and one small indoor unit. And now we see things like multi-splits where you have one outdoor unit and multiple indoor heads. So you can put them in different rooms, or indoor part units that are like radiators, or ones that are in can be installed like in a drop ceiling, so you can have like a small ductwork coming off of it and reach different applications. So I think the big applications or innovations are all coming in how you actually get them in the house, and then how they're controlled.
Okay, great answer. Excellent question, don't you think?
Yeah,
that was mine. Okay, the next question is from Larry Gilbert. Are there any heat pumps you recommend that are made in the USA?
Are there any that are made in the USA?
Yeah, I don't know. I'd have to look.
Yep, I'd have to look. To be honest with you, I wish I could answer that easily. I really do. But the Mitsubishis, I'm pretty sure, in Japan, and the Fujitsus, these are two higher than ones that I know of, are made in Taiwan, I think.
Okay.
Good question. I hope somebody answered that for me.
Okay, we'll move on to the next one. I actually knew this one's coming.
Yep.
Can you explain what SEER, or Seasonal Energy Efficiency Rating, is?
He pretty much explained it right by saying that. Seasonal Energy Efficiency Rating is the efficiency of the unit, and usually that's, like he was saying, the modulating compressors have gone a long way as far as efficiency, running higher when they need to and lower when they don't need to. I know on the heat pumps, when they get down to a certain temperature, like let's say you've got it set at, for cooling, you've got it set at 74. When they get down to like 76, they run on lower speeds and say to dehumidify more and to cool less, because you want to run it longer to dehumidify longer. Seasonal efficiency ratio. And other than that, it's basically the size of the unit outside and inside, because the bigger the coil area, the more heat transfer you get, both inside, getting more heat or cooling out of your refrigerant, and outside, picking up more heat or cooling out from the outside air. That sound right?
Sounds good to me.
Yeah.
Okay, next question from Fired Up again. Oh, this is a good one. Is there any way to monitor your heat pump while you're away from home?
Yeah, I mean, most of the big manufacturers with their higher end equipment have some sort of web interface. It's usually through the thermostat. So whether that's from the manufacturer or from a third party thermostat manufacturer, your Nest or your Ecobee you can set those up so that they're accessible online.
Okay. And a follow-up, how do they work when it gets really cold?
Yeah, this is a question I get a lot, is that, it's hard to believe that at -20, you can still transfer heat from outside to inside, but the technology can do it. So it uses refrigeration cycle, and it can move heat at really cold temperatures. And they just, like I said before, the ones that are really designed for that application have the capability to kind of ramp up as it gets colder and colder, so they can extract more and more heat. Their ability to do that does decrease as it gets colder, just because there is less heat source available. But I've installed some on the North Shore of Lake Superior that we had monitoring equipment, and they were putting out a ton of heating at -25, 28 degrees. So they can do it.
I guess that's a very relevant question for both New Hampshire and Minnesota.
Yep.
Definitely is. Yep.
Next question. How would you describe the environmental impact of heat pump adoption in New Hampshire or on a national scale? Tim, you want to do New Hampshire, and maybe Ben go for the national?
Yeah, sure. Well, I mean, New Hampshire or national, same thing, pretty much. Like Ben said, you don't have any fossil fuel that you're burning, so that's better for the environment, I'm quite sure. And you're not using up fossil fuel, which is also the same thing. And there's less impact that way, anyways. So
yeah, and they're super efficient. So it's kind of the best way to heat your home from an environmental standpoint.
Okay.
Maybe not the best, but it's up there.
Yep. I agree.
Next question is from Norma Jo Sortman from Facebook. Can we use heat pumps with our existing forced hot air ductwork?
Yeah,
Yes.
so we've done quite a bit of that in our work. So looking at replacing gas furnaces, or at least partially offsetting the use of gas furnaces by essentially replacing your central air conditioner with a heat pump to do some or all of the heating in your home.
And Tim, do you actually do a lot of this stuff in your line of work?
Yeah, quite a bit actually, because you can either take out the existing gas furnace and put in a dedicated heat pump. But what people usually will do is put in a heat pump coil, which is an air conditioning coil or a heat pump coil, over the existing furnace, use the existing blower. And as long as you can figure out a way to wire the controls in, use that outside either to heat or cool as an auxiliary, heat pump, either heating or cooling. Yeah.
Okay. Great. The next question is, what are the common misconceptions you guys hear about heat pumps?
I mean, I think the biggest hurdle we have is just, it's hard to believe that they work in a cold climate. And so that's probably the biggest one.
Yeah. And again, the heat pumps that they used to install in the late 70s and the 80s that really didn't work when it was below 20 degrees and people were heating with just electric backup. It is amazing to me, because I've been doing it around it for so long, that they really do work at 20 below, and they're pretty efficient even then. So yeah.
Okay. Next question is from Scott Silva, one of our associates here. Would heat pumps be a good solution for a tiny house?
Yeah.
Yeah, I mean, in fact, heat pumps are one of the few. I mean, it's a lot harder to get some of the traditional HVAC systems at the sizes necessary for a tiny house. So yeah. There's actually some really good fit there. And if you do a good job building your tiny house, you shouldn't need backup, because the heat pump should be able to provide enough heat at cold temperatures. We've seen a couple of well-insulated, probably not tiny houses, but smaller houses in my climate that's pretty cold, that just use a single mini split as its only heating source.
Okay. And the next question, are commercial building heat pumps large, massive units, or a set of distributed smaller ones? And how do office airflows different from homes? That might be for Adam, but you guys want to take a shot?
Yeah, so I guess the big thing to say about that, so there are VRF systems, or variable refrigerant flow systems, which is a more commercial system. The distinction between VRF and air source heat pumps is kind of fuzzy, but those are traditionally the kind of commercial scale heat pump applications. But we do also see, especially in multifamily buildings, where they also just use a bunch of smaller residential sized units. So both solutions are being used.
Okay. Tim, anything to add?
Oh no, I agree pretty much with what he said. Yes,
Okay.
there's a lot of different ways they can convert chillers to do a whole building, but as far as most of them, as far as apartments, things like that, they're better off having their own unit, because that way they're also paying their own electric bill for their heat or cooling. So separate small heat pumps really fit in pretty well for that.
Okay, the next question looks like we're looking for an all-in-one. They're combined heating, cooling, hot water heat pumps.
Yeah, so those systems that I was mentioning before that are more common in Europe that are starting to make their way over here, those are more combined applications. So they'll do heating, cooling, hot water, kind of all in one. There aren't a lot of those probably installed in the U.S. You could probably count them on a couple hands, but they are here. I've seen a couple of them.
Okay. Let's see. What are the cost trade-offs in new construction versus traditional HVAC? And what are the long-term expenses like?
For that, you would be talking about using one central heat pump as opposed to a gas furnace or an oil furnace, then, I'm guessing.
Okay.
And actually, I think the price would be pretty close to the same. As far as efficiency, you'll make up better with the heat pump than with a less efficient oil, or possibly, well, gas is probably pretty close to even, because gas is more efficient, and natural gas is a little cheaper. LP is a little more expensive, but that's just what I'm saying off the top of my head. But
Right. Our next question comes from Jeremiah McLean. Can you talk about the maintenance for the compressor and the mini splits?
Maintenance, they're pretty much maintenance free unless something breaks down. I mean, the maintenance, of course, you have to do with any hot air system, if you're using hot air, is change the filter, or clean the filter, or change the filter. Other than that, I don't really know of any maintenance to do on that or an air conditioner unless something breaks down on it. If that's what you're asking.
Yeah. I don't know if you've seen this, Tim. We've seen a lot of manufacturers claim, we haven't done anything sort of long term, so it's hard to say for sure if this is true. But a lot of the manufacturers, at least of the higher end heat pump equipment, have really strong modulating features, so they can run at a really low rate when needed, and so they'll run for a really long time. So instead of being on and off like a traditional HVAC system, they run pretty consistently. And for compressors, that actually reduces the wear on them quite substantially. And so they claim their compressors live much longer than a kind of traditional single stage air conditioner.
Oh, I totally agree with that. Yeah. I mean, just the ones in my house, if you can do just pretty much any with the Mitsubishis, the Fujitsus, because you can do a lot with controls. But again, with the AC, that'll run down to high speed down to 2 degrees of the set point, and then it'll run on low speed for a long time, which is more comfortable because you want to take more humidity out of the air, and you don't have to run as hard. So I agree with that. The rest is supposed to last a lot longer.
Yeah, we've seen cycles on these things that are like weeks long, because they figure out exactly how much heat or cooling the house needs, and they just lock in and match it exactly.
They're adaptive. I think the right word is adaptive to that. They're intelligent adaptive controls.
That sounds great. Yeah.
Okay. Another cost question from Larry Gilbert. How much on average does a heat pump add to the electric load of the home? Well, maybe that's not a cost question. Does the heat pump add to the electric load of a home?
Are you talking about just it cost to run per day, or?
Sure.
I can actually say at my own house last summer, I ran the cooling all summer because it was a really hot summer and I was home a lot. And my electric bill went up an average about $2 a day, which really isn't too bad if you think I was completely comfortable for less than a cup of coffee per day. You know, I was impressed with how little that added to my bill. And that's a 2,500 square foot house. So,
all right, this may be our last question. What new improvements are on the horizon? Are there any advances in materials that will change the heat pump game?
Want to do this one? I'm just a plumber.
Advances in material. The biggest thing that that jumps to mind to this question is just increasing looks at alternate refrigerants and trying to find actual refrigerants that have lower environmental impacts than what we are currently using. And that's a really open question. If that change will come and when it will come and what the new refrigerants will be and what impact they'll have. So it's hard to kind of say, but that's the biggest thing I think of in terms of like materials for heat pumps.
So
there are some more like niche things that I don't know if will ever work out. Like, so one thing that happens with heat pumps is when it's cold out, you can, when it's sort of moderately cold out, the outdoor condenser can kind of get some condensate buildup and can potentially freeze. And so they do have to run a defrost cycle. I know people are looking into things like a coating for the outdoor coil that would not allow frost to stick to it, basically. If some of the stuff like that works out, that could have a pretty big energy impact. But that's kind of that's definitely academic research at this stage. We'll see if it comes to market.
One last question about costs. In New Hampshire, we are paying almost 19 cents per kilowatt hour. Would a heat pump save money over a high efficiency oil burner for heating? Oil is about $2.60 a gallon.
It's a lot of conversion.
I think
in real time.
They're probably pretty close. It depends on how efficient his old oil system is, to be honest with you. Does he have a new system?
Don't know.
Yeah. Relatively close.
Relatively close. Okay.
Yeah, that's a pretty high electric cost, but oil is really expensive. So I think you're probably right. I could run some numbers, but it's probably about break even.
Okay. So that's it for the questions. Before we go, I'd like to ask both of you, Tim and Ben, are there any last comments you'd like to make? Anything you'd like to leave with our audience, or anything you'd like to reinforce about heat pumps in general, or cost savings as related to heat pumps? Tim?
Well, basically, pretty much what we went over. I liked what we covered. And again, the high efficiency part is really impressive. And the heat pumps that works at so low a temperature is really impressive too. And I'm installing more and more of them. I'm a very small company. I'm just myself right now, but they really are a good deal. And I think if anything, the only problem we're going to have this summer is availability, because everything is just, the prices have gone through the roof on manufacturing, and the manufacturers are going to run out. And so that's going to be a pain, but yeah, I think that's about it. I think you covered pretty good.
Ben, any last thoughts?
Yeah, I mean, I guess I just echo kind of what Tim was saying. I think, we covered a lot of good stuff. I think there's a real good applications. Most people have a heat pump application that would give them some benefits. So it's definitely a technology worth considering.
Great. Okay. So as we wrap up for this evening, I would like to remind everyone that this episode, as well as many of our episodes from the past, will be available for viewing and sharing online at our Facebook and YouTube channels. And then first, I would like to thank our audience for being with us tonight and for submitting the questions and participating in this session. Next, please join me in extending a special thanks to our panel. As always, they have been very gracious with their time and their expertise, and we certainly appreciate it. Thank you so very much.
Thank you. It was enjoyable. Thank you.
Thanks for inviting me. I was happy to be here.
Great.
Pleasure.
And then finally, we hope to see everybody again next month on May 19th, the third Wednesday of the month. Science Cafe will be on electric vehicles.
Okay.
And on that particular day, it will be our first anniversary of Science Cafe's virtual sessions.
Mm.
And it will more importantly be the 10th anniversary of Science Cafe of New Hampshire. So again, thank you all for joining us tonight. Have a pleasant evening and good night, everybody.
Thank you.